Short question. Whom of you is already using TypeScript? Cool. So just a really brief short recap what it actually is. It's a superset of JS. It compiles to JavaScript because that's the execution format of our browser or Node.js. And each JS is a legal TypeScript because it has backward compatibility with JS. And of course, TypeScript implements all the following ECMAScript standards and the newest one also. And of course, it's optional, statically typed. So maybe something about the type system. What we can say about it, that is optional static typed. So you don't have to, but please do it. Don't leave next person with the code like any. It has structural type system with appendix, and it's as strict as you want. So I think that the language is totally on the right part of the chart, the good type system, but the region of optimal pain depends on how strict you want it to use. Okay, so it's a structural type system with appendix because actually nominal type systems are coming, hopefully pretty soon. By the way, subscribe Wrocław TypeScript. I think that you do it. They're posting good stuff, and they found it. I won't be talking about nominal types anymore today, but just to mention. Okay, so let me just put some popular languages on the table of the type systems with the types check, so during the compilation time and the runtime safety. So of course, we have the dynamic and weak JavaScript. On the other hand, we have the static and strong Java or C#. And here is the TypeScript, static, optionally, static typed during compilation time, and of course, weak during runtime, so no runtime type checkings. And of course, that's the nominal type example. Those two classes have the same structure, but they're you cannot set one to another because it's totally different type. It's, let's say, different metadata behind that type. And in the structural, it's everything about the structure. So we can set the higher type to the subtype, but we cannot do the opposite. And of course, this is life. Everything is possible. So, unfortunately. But that was only the short introduction. My name is Michał Michalczuk. I came to you from Gdańsk, where I just started working in Spartes. For Atlassian, I'm currently working on Jira Cloud. And beside that, I'm an IT trainer in InfoShare Academy, also in Gdańsk. And I want to talk about you today about modeling data with TypeScript. So one thing to mention about that, for sure you know the concept of ADT, algebraic data types. If you don't, you have to know two common algebraic data types. It's the product, the Cartesian product, actually, which in TypeScript is realized by tuples. It's done by tuples and by records, aka index types, and the sum, which is done by the union type. So it's OR. It's just OR. Also, end of topic. And let's take a look at some challenges with your models, not problems with your data, because the data can be totally different. In my opinion, a lot of problems lie in your models, and they are just the challenges. So imagine that kind of shining data which your API served. We have here actually two kinds of product. Part of products are type stack, part of our type marketing, and they have different fields. As you can see, some fields are only for stack product, some fields are only for marketing product. So imagine the type we can write. Okay, we have the union literal string of the type, it's stack or marketing, and we have a bunch of optional fields. And I see here few significant problems. First one, imagine all the ifs of the optional fields. Are they set or not? And where should they be set, in which scenarios? We don't know it from the type, so it definitely sucks. But let's improve it a little bit and use the discriminated union type. And like take a look at the code, or maybe just play with it. So I have here the same two types. First one is the marketing product. It has all the common types which I had previously, so ID, type, and description. And the stock product it also has ID type and the stock specific fields, same as here I have marketing specific fields. And I have one field which can be the discriminator, which always will have the unique value, and by which I can distinguish those types between them. So first is marketing, and the type has to be marketing. The second stock, and the type has to be stock. So then let me create the union type from it. Let me call it product. As you can see, it can be marketing or it can be stock. And here, of course, I can see only the fields which are common in those two types. But if I would like to actually use the fields which are in stock product or in marketing product, I can do it in a few ways. The simple way, let's call it the if way. Let's check if the product type is marketing. If it is, then the compiler knows that, okay, that it for sure has to be the marketing product. So I'm able to use all the marketing stuff from here. If not, I have only one union, so it totally has to be stock product. Win-win, totally done. This code, of course, won't compile. So that's nice. Let's extend it a little bit, and let's do it in my opinion, better way, the guard way. So let's write a short function which can verify, which can tell the compiler actually that, okay, that parameter which you gave me, I will tell the compiler that this is marketing product. So we can also use that and add here some logic not to copy paste it everywhere. And I'm pretty sure that this is the scenario that you're, at least most of you, are familiar with. It's quite common. But okay, I forgot about that slide. Let's improve it also a little bit, and let's cut some code duplication in our fields definition, and let's create some base product. If you know Python, you for sure know that beautiful convention with two underscores in the beginning is just some internal type which I have in my module only for sake of not copying those two fields. It shouldn't never be exported, and the rest is of course the same. Okay, so I think that I improved my primary model. Now it can be managed way better, and I know which fields in which scenarios are available and which are not. So let's take a look at another example, another possible problem or challenge. Call it whatever you want. We have the multiple API versions. The backend guys are currently migrating from version 1 of the service or that particular endpoint to version 2. And I'm really glad because they are giving us the version as a number in the response or in a header, whatever. But also we have a bunch of fields which are optional because some are only in version 2 and one that's beautiful was created on date was removed in version 2 as not semantic and not making any sense. So the problems also ethology a lot, And also, we don't know which fields are actually used in which scenarios. The type doesn't provide us that information. So, how we can fix it? Okay, let's do the same thing. Let's also apply the distinction union type. Let's create the client v1 with version 1, which would be the discriminator in that case. Let's also create the client version 2 with the client version 2 specific fields plus the common fields plus the version 2. The rest will work absolutely the same. I can also add here a guard or a if. No, not a difference with between this and the previous example. But I think that we can improve it a little bit because right now we're doing one terrible thing. We're copying all of those fields from the previous snapshot. So it's more than a snapshot of a version than like a schema migration. And I would like to do something like schema migration. So let me improve it a little bit. And let's create the client v1 with the ID, name, version, and was created specific only for version 1. And then, while creating the client v2, let's use some type helpers from TypeScript. For example, in this case, omit, and add here, let's call it part of the migration of the type. So, okay, TypeScript, please take the client 1, but omit from it the was created on date field, and add there by the intersect type, add there the new stuff with version and with the created on and ref IDs, which are specific only to version number 2. Fair enough. We omitted part of copy pasting the fields. It would be, in my opinion, way better to maintain. But maybe we can do something little more. I created a short type helper, which needs some more love, but it partially works. I call it version, which takes the version which has to be number, and the type it will be extending and just returns a simple intersect type between the new version, and the type. And I have my client v1, which is created by my new helper with version 1 and the primary fields. And as you can see, it looks the same as previously. So cool. Let me then create the client version 2 using the same pattern, with here adding the new version and here adding the migration. Let's call it. And that might not be as that clear, but it also behaves the same as previously. And of course, the same we can do with the next versions and so on, and reduce the amount of fields which we're just copy pasting. As I mentioned, that helper needs some love because version should be, in that case, free, but I already spotted the error, so please check this presentation, I don't know, in 2 days, maybe tomorrow, I'll update it. But that's, in my opinion, something which we can do with not that much amount of work. Okay, thank you, Chrome. Okay, so what other problems I see with our models? Something called types pollution or classes pollution, if you would write it in Java or C# as I used to do, that at some point amount of classes which are some simple DTOs or models or plain entities is huge, and it's hard to maintain, and you don't know what's actually going under. And this is the first step to it. because this one, that phone features, which is used only on the phone features, on the features field, should be, in my opinion, internal. So types pollution, definitely. And those types can be exposed from this module and used somewhere else, and it would make an additional mess because there is no need to do it. So in a few steps, what we can do with it? Nothing. Give him a second. Okay. Cool. Okay, so option number one, let's just inline this type. We can do it, why not? So it wouldn't be explicitly right type, but what if we want to use actually the type that's behind the features field? Let's use the index type. And here, let's say, okay, please take me the type which is behind the field feature in the type phone. And as you can see in that yellow box, it's that particular type. So check that we can still use the type and don't pollute our code with the new additional types. I really love this feature. It saves me a lot of mess in our code base in that kind of situations. Okay, but still there is one smell here. Thank you. But still there is one smell here. The promoted feature, which, as you can see, can be either is waterproof, RAM amount, or CPU, which are just a features, right? A field name from features. So maintaining it in that way kind of sucks because you have to update it manually, which always sucks. So what we can do? Let's just use the keyoff with combination of index types. And as you can see, we can do it in a recursive manner. So we can use that type which we're currently in. Case closed, right? No more typos, no more writing it manually. Win-win, right? As you can see, it's definitely that what I wanted. Okay, but maybe let's add some additional stuff and do some TypeScript code which sometimes looks like a git merge conflict in your file, and let's create a checks. Why? Because that kind of flags, let's call them, most of the times have to be lazy loaded or loaded on the action, on the trigger. So it would be nice to create something like feature checks. Let feature checks 2, which would have fields like CPU and so on, which would be a function returning that type which this flag is. So in this case, string, right? It would be nice to not do it manually. So I created here also a short, nice-looking type, which for which key in phone features requires the function which returns the return type of that field. Let me just show you how it looks like. Right? And done. This should return, I believe, some string. This should return, I believe, a number. So let's return a string. Farewell, my compiler. And that should be Boolean. So also let's do this. Okay. Almost. Freud would laugh. Okay, right? Working. No manual work, no manual maintaining that stuff. I can handle it by types. Nice. So maybe even more examples. We can go deeper in the rabbit hole. Wait a second, that one is not that important here. This is more important. Please take a look at the client. Client has address and address has country. So we can totally go to client, take the address from client, and from that address, we can even go deeper in the rabbit hole and take the country. So the country will be string, right? Sometimes it makes sense. Please don't overuse it. But yeah, why not? It's still valid. Okay, so but what about tuples? Sometimes our API responses or just our types, our data is just a tuple, just an array with, I don't know, some row that on the first place in the array you have the ID, on the second you have the name, on the third you have the full object or something like that. So how here TypeScript can help us? We can create a type which is modeling tuple, and in this case I'm telling TypeScript that, hey, dude, on the first position of that type, which is a tuple, would be that short inline style, so object with ID. On the second position would be client. On the third, it would be contract. So I have my row, which is type assert. Don't do it at home. As client row. So row at position 0 is ID, right? At position 1 is the client, and on position 2 is the contact, right? So nice. I can also, of course, do the deconstruction, and it would also make sense. X, Y, Z, right? So even if your data looks that way, it's not the problem with your data. Maybe a little bit, but you can totally handle it by types in TypeScript. Okay, so tuples checked. But what if you actually don't want to type some fields? Why? I don't know, because you're just passing them through your app or service. In the previous company, we had back and forth frontend, which was a lot of times just passing the data, maybe reading 2-3 fields, doing some little logic and passing it to the client. So why should I put there the types? We didn't have the common types registry back in the days. So why to use the work which no one needs? Sorry. Or for whatever any other good reason, you don't want to do it. Thank you. Okay. Okay, we have two options to do it. We have the any and unknown. Any, the evil twin, is literally anything. And you can call anything from it. And you can assign anything to it. The unknown, which is from TypeScript 3.0, as I remember, please correct me if I'm wrong, it's literally unknown. You're just claiming that I don't know the type, I don't know what it is, so I shouldn't be able to access or call anything from it because I don't know what it might be. But I can assign anything to unknown because it's still unknown, right? And any mostly can be avoided. It's in general bad practice, but sometimes it's your last hope. and sometimes it's a quick fix. I have an answer on Stack Overflow with about 200 apps where I answered, yeah, the simplest way is to type assertive as any. If not, please write the own interface or do other stuff. 200 upvotes. But it's still sometimes a solution. Sometimes. And unknown is really perfect for just passing the stuff which you don't want to touch, just want to pass it through your service or application. And it's quite safe. I consider it quite safe because you won't do anything stupid unless you assert to any. Okay. So let's take a look at it. In unknown we trust. I have the client with the unknown address, which is type unknown, and with any. I have my client created, and as you can see on any, I can do, as you know, totally everything. It compiles, right? That's any. But if I would do something with my client dot unknown address, for example, let's set there 42, universal answer to everything. Yeah, it works. Okay, so the compiler should know that it's number, right? Wrong. It's still unknown, right? It's just still unknown. You cannot call any action on it. You cannot access to anything on it. It's just totally unknown. If you want to do it at some point, you know that this is totally that type. Compiler, please hold my beer. And you're doing the type assertion, praying, and sometimes it works, right? And that's the official way of just using it. Okay, so any versus unknown, done. So some other problem I found. How about the data? It's a collection of clients which has the continent acronyms. This one is from Africa. Okay. The second one is from Australia and Oceania. The third one is from Europe. Europe looks like a really nice dictionary, but a short one which we can actually write like this, right? Makes sense. We have only 7 continents, so come on. But also, I think a few problems. It's not value type. It would be nice if it would be enumerated. And by the way, why we have to use the API values? Maybe it would be nice to use some readable names. So, of course, we have enums for that. And since few versions, I don't remember when it came, but it was some time ago, in TypeScript 2 point something, we have string-based enums, same as Java. TypeScript don't have it, or maybe something changed in the new .NET Core 3 or C# 8. I assume not. Okay, so they don't have it still. Unfortunately, here, absolutely, we can use it. So it's the value type. Everything is nice, right? We can use it as that kind. We can do the conditional logic here. Everything looks great, works great. But enum has its evil twin also. And a few days ago, I saw a few posts on Twitter where people were beating around enums, simply just not using them correctly. But what I wanted to show you, this is the good twin, right? We have the enum continent, and on the right you have the JavaScript distribution which is the result of the compilation, right? It just creates the object with continent. Let's keep it that short, right? Right? And what about writing const on the front? Still compiles, right? That's a really odd behavior, in my opinion, of TypeScript, but it's kind of real that if you add const before the enum, everything still works. Compiler works perfectly, it matches it, but it didn't produce any code. Oops. Happens. And we had that kind of bug because someone did it, probably not intentionally, but oh well. So that's the evil twin of enum. Ha. Okay, and speaking of enums and types, where we should put our types, where we should put our models? Well, of course, we have files like d.ts, which are the files for the definitions, and just a plain TypeScript files with the .ts extension. And to handle the definition types, historically we had the definitive type, still lives somewhere. We have the typings. We had the typings actually. I remember how it was born and buried, same as DTS. And now we have alias types as a set of repositories on the GitHub, where the types, not GitHub, the set of packages on npm, which are the types, or the library's authors just included in the source code, which is preferable way. But using the DTS in your own code, if you're not maintaining a library, not creating a package which you would distribute as a JavaScript, not as a TypeScript, it's living on the edge if you don't know what's the output of that kind of files, right? Because this is the DTS file. I know that it doesn't look like from the address. Oh no, it coded it. Okay, sorry. But in the DTS file, you cannot, of course, create class. Why? Because class has the distribution code. It actually generates some code, so you cannot do it. You can do only the declaration. Same as functions, same as any values, but you can do that kind of strange things like declare const with some value, okay, with the DTS. You can, of course, declare the type, declare the interface, and declare the enum. You can do it. It works perfectly fine. But there is one nasty thing, actually two, with it. It's totally living on the edge, because if you're compiling the TypeScript file, for example, with this enum, yeah, you saw that result before. It just compiles to that nice object. But if you do the same with the DTS, it compiles to nothing. Why? Because DTS files, they only definitions, right? There wouldn't be any executable code there, but it's still totally valid for a compiler to put it there, right? So you don't have the value type, and it can cause a lot of odd errors. Living on the edge. Another one. Let's check this one. Declare const Poland is a code equals PL in TypeScript and file and in DTS file. Compiles to nothing, both, right? So it's also kind of odd that you can do it. It totally doesn't make any sense. So also it can generate really odd behaviors, unless you want to declare global variables in window, right? Then this is, I think, the only in window. I think that this is the only application of it. Of course, leave. Okay, and with these few lovely examples, we reach to the summary time. So, if I could give you some advices about how to model your data, is to check and use that TypeScript rich types toolset, all the types helpers which are I don't know, the filter, the div, and so on and so on. The return type, there is a lot of it, and they're absolutely nice to use and easy to use. Type, and type. Just type your code, not with any, please. And remember that JavaScript elements, remember what kind of TypeScript elements have the JavaScript distribution, right? Like enum and so on, which I just showed. Try to avoid types pollution, or you'll finish with all the Java and C# diseases that I've fighted over the years. But please be rational with using that kind of stuff. And if your code started to look like a git merge conflict, you're somehow overusing it, in my opinion. And that was all from me. Thank you very much. I think that we have a few minutes to some questions. You can find the presentation here, also with the link to the Stack Blitz, where I have the examples. You can catch me on michalczuk.xyz and on my Twitter. And thank you very much.
Thank you, Michał. Any questions? Hang a second to the microphone.
It isn't strictly related to the presentation, but just want to hear your opinion of when to use type and when to use interface.
Okay, I wanted to even add it to the presentation, but my final thought was that it's not the essence of it. Okay, class, type, and interface. I'm using class only where I'm actually creating something by using new or something underneath is actually creating new objects. Why? Because then it has the prototype. And then we have the type and interface. I'm using type to almost everything, especially to model data. And interfaces I use only in two cases. If I actually want to model some behaviors, and that behaviors can be implemented by some class. So like in a classic paradigm of OOP, I'm using that way the interfaces. Or if I'm trying, or if I need to use the interfaces merging, right? Because interfaces merge, types has to be unique. So if you're using jQuery, we all love jQuery, with TypeScript, and you have some custom plugin to jQuery which doesn't have types, and it would be nice to write in TypeScript and write $. My new fancy shiny jQuery extension, you can just write the interface called jQuery, add the types, and it will be merged with the jQuery interface came from the definition files from the jQuery. So that's my. Did I answer you?
Thank you.
Yeah. Cool. Guys?
Who's next?
Don't be like that.
Okay, thank you.
Thank you.